Hello everyone, how to solve this problem for the values of k if we have k is equals to minus times square root of k and we solve this problem for all the values of k. So here we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. So here we solve this problem for first method. So in the first method, we cannot take scaling on both of the sides. Okay, so here we do not take scaling on both of the sides. Here I can just introduce another simplest technique in which you can easily get the roots of this equation. So here we use the radical technique. So first we move this minus square root of k into the left hand side, and it will be written as k plus square root of k is equals to 0. And now here we use the nice rule of radicals, and according to this rule you know about that if we have a number 2, we write it as square root of 2 multiplied by square root of 2. Okay, so according to this rule we write this k as into the product of multiple of square root of k multiply square root of k. Okay, this will again get k, and plus this is our square root of k, and this whole equation is equals to 0. And now here in the next step we need to take common square root of k from here, and when we take common square root of k we get the remaining values are square root of k plus 1 is equals to 0. And now here in the next step we need to divide this equation into the two cases. The first case is we write square root of k equals to 0, and the second case is we write square root of k plus 1 is equals to 0. And now here we need to remove this square root sign, and for this we take squaring on both of the sides, and when you take squaring it will become this 2 and this square root are gone, and we get here k equals to 0 because the square of 0 becomes 0. And from here we move this plus 1 to the right hand side, and it will be written as square root of k is equals to minus 1. And here for the values of k we again take squaring on both of the sides, and it will be written as square root of k whole square equals to minus 1 square. So this 2 and this square root k are cancelled out by each other, and we get here k is equals to, here we know about that, minus 1 square becomes plus 1. So these are the two roots of the given equation which we get here from first method. And now here in the next step we need to verify that is these two values of k are satisfied our given question statement or not. So that we need to copy down given question statement. Here it is k is equals to minus times square root of k. So in this side we will be verify k equals to 0, and in this side we will be verify k is equals to 1. So when you put k equals to 0 on both of the sides, it will be written as k equals to 0 equals to minus times square root of 0, and we know about that 0 be the neutral number, so it is not positive or negative, so this negative sign does not affect on 0, so it will same becomes here 0. So this means that, or this shows that both of the sides are equal, so k equals to 0 be the first solution of the given equation. And now here we verify k equals to 1, so we put this value on both of the sides of above equation, and it will be written as 1 is equals to, we know that square root of 1 equals to 1, and this is minus 1. And here you know that 1 is equals to minus 1. This is not possible case. It is not possible that positive 1 is equals to negative 1. So here we just say that k equals to 1 is not satisfied our given question statement, so we call that k equals to 1 be the extraneous root of the given equation. Okay, so this is the extraneous root, and because k equals to 0 is satisfied our given question statement, so we call that k equals to 0 be the solution set of the given equation. So this is the value of k, and now here in the next step we again solve this problem for second method, and in second method we need to copy down given question statement here, so that our given question statement is k is equals to minus times of square root of k. So here in the second method, we just take squaring on both of the sides and we quickly get the roots of this equation. So in order to remove this square root sign, we need to take squaring on both of the sides, and it will be written as k square equals to minus times square root of k and its whole square. So we get this is k square equals to minus square becomes positive and square root of k square becomes k only. And here we move this k from right hand side to the left hand side, and it will become k square minus k equals to 0. So here we need to take common k from here, and when we take common k, we get the remaining values are k minus 1 equals to 0. And in the next step, we need to divide this equation into the two cases. The first case is we write k equals to 0, and the second case is we write k minus 1 equals to 0. So this is the first root of the given equation, and from here we get the value of k is equals to plus 1. This is the second root of the given equation. So here in the first method, we already verified that k equals to 0 is not satisfied our given question statement. So we call that k equals to 0 be the extraneous root of the given equation. Okay, so k equals to 0 is satisfied our given question statement. So we call that k equals to 0 be the solution set of the given equation. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.